In this question, we're asked to solve 4 cot squared theta equals cosec theta plus 1 for the range 0 is less than or equal to theta is less than or equal to 360. Initially, we need to start off by identifying what we're going to do with this trigonometric equation. The thing that I notice, first of all, is that I do actually have a quadratic term. That indicates to me that I'm going to use some sort of Pythagorean identity in order to get a substitution to make this quadratic all in terms of one function. If you're unsure which one to use, remember that you can write the original Pythagorean identity and then decide to divide by cos or sine, whichever will give you cot. Now to get cot I need cos over sine, so I'm going to divide everything by sine because here I will get cos over sine. And once you get used to these, you will start to learn them, but if you learn to do it by first principles, you'll find you learn them a lot quicker. Okay, so the identity that I'm going to be using is going to be cot squared theta plus 1 equals cosec squared theta. And this isn't quite the substitution I want, so I'm just going to rewrite and make sure that I'm clear of the substitution that I'm using. Cot squared theta equals cosec theta squared minus 1. So now I'm going to substitute this into the equation. I'm also going to rearrange the equation at the same time, so just take care doing this. Just trying to save a little bit of space. So we get 4 cosec squared theta minus 1. I'm going to subtract the cosec theta, and I'm going to subtract the 1, so it's equal to 0, and we're getting closer to that quadratic form already. If you need a couple of steps to do that, just take a couple of steps to do that. Okay, so expanding and simplifying, I get 4 cosec squared theta. I'm going to get minus 4 and minus 1. I'll deal with that in a second. So cosec theta, and so minus 4 minus another 1 gives me minus 5 equal to 0. Okay, so now I need to factorise the quadratic. Remember, if you don't like factorising with a trigonometric function, write it in terms of the first initial of the trig function that you're working with. So here I'll just do it to the side. I've got 4c squared minus c minus 5. I don't need to write it as an equation necessarily. I'm just going to write it as an expression so that I can factorise it. So 4 times minus 5 is minus 20. Factors of minus 20 that give me minus 1 will be minus 5 and plus 4. So I'm going to have 4c plus squared plus 4c minus 5c minus 5. Factorising, take the 4c out as a common factor, I get c plus 1. And for the second bracket, if I take minus 5 out as a common factor, I get c plus 1. So it factorises to give me 4c minus 5, c plus 1. Okay, I can now apply that to my equation. So I get the function equation 4 cosec squared theta minus 5 multiplied by cosec. So there shouldn't be a squared there. I'll go back and change that in a moment. Cosec plus 1 equal to 0. So let's just get rid of this cosec squared here. So apologies for any confusion there. Let's make this clear. So it should just be 4 cosec theta minus 5. So that means that solving 4 cosec theta minus 5 equal to 0, I get cosec theta equals 5 over 4. And solving cosec theta equals at plus 1 equals 0, I get cosec theta equals minus 1. Now remember that this means 1 over sine theta equals 5 over 4. And so 1 over sine theta equals minus 1. So I'm going to invert the fractions on both sides so that I get sine theta equals 4/5. And on the right hand side I get sine theta, and minus 1 over 1 is just minus 1 still, so it doesn't really affect it there. So finally, just solving the equation and finding all my solutions in the range. taking the inverse sine function on both sides, take the inverse sine of 4/5, my principal solution comes out as 53.1 degrees, and then my paired solution will be 180 minus 53.1, which gives me 126.9 degrees. If I then do sine of the inverse in sine function on -1, what we are going to get is minus 90 degrees. Now when I subtract that from 180, I get, let's just undo that last stroke a second, minus 90, I get 270 degrees. And actually 1 and -1 are special values for the sine curve because there's only one value equal to 1 and -1 in the range 0 to 360. So my final answer will be 53.1 degrees, 126.9 degrees, and 270 degrees given to one decimal place. Okay, I hope that made sense and that you was able to follow my solution.